Okay, well, we're going to get started. My name is Jules Damji. I'm the Spark Community Evangelist with Databricks and developer advocate. I want to thank Capital One for really hosting this, and MetaStream is one of the co-organizers. We're really delighted to be here. Happy to see all of you here on a Saturday. You could be doing a lot of different things, but to see all these people over here actually gives me an immense confidence to be an advocate for Spark community and to see all you here on Saturday. It's really a pleasure to introduce my colleague from Databricks, Richard Garris. Richard Garris is a principal architect and a solution engineer for Databricks. He's been with us for a few years. And his principal aim, his goal in life is really to shepherd and bring customers using the advanced analytics and showing them how to actually productionize and design and implement the machine learning tools. Prior to joining Databricks, he was at Google and at Skytree. And please give a warm welcome to Richard Garris.
Thanks, Jules. Yeah, well, welcome everyone. Thank you for coming here on a beautiful Saturday morning. It's great to see everyone. So we're going to talk about how to productionize your machine learning models. So how many people in the room are data scientists? So data scientists, okay. Engineers, like computer software engineers, okay. A large portion of engineers. Other, are you guys business analysts or business users? Any business users? All engineers, awesome, I love this. So a little about Databricks, and Jules did a great intro for this. So Databricks is one of the commercial companies behind Spark. So our co-founding team started Spark in the AMP lab in 2009. Our real mission in life is really to make big data simple. For me in particular, it's really to make machine learning simple. It's really the ability to take data, apply algorithms to that data, and come up with predictive models in a much easier way than you do it today. A little about me. So I spent most of my career, early career with PricewaterhouseCoopers, doing data management consulting. I went on and did some time at a couple of small startups called Google, also some time at Twitter, and now at a big company called Databricks. So I'm also an Ohio State Buckeye. I'm going to watch them at 4:30 today. Go Bucks. And I also got my master's degree from Carnegie Mellon. All right, so a quick outline of what we're going to cover in the talk today. So one is some general information about Spark MLlib. How many people have used MLlib before in the room? Okay, about a good amount, okay. I'm going to talk about model serialization, how you can save your model, as well as how you can set up scoring and your system requirements around scoring those models. I'm going to talk about some different architectures for how to do scoring from real customer use cases. And I'm talking about a little about Databricks and what we're doing in terms of model scoring as an overall solution. So Spark. So obviously this is a Spark conference, so everyone has probably seen this stack diagram. So at the core, you have Spark Core, which is a very fast engine for doing distributed processing. On top of that, you have various libraries. So you have Spark SQL, Spark Streaming, MLlib, and Graph Frames. All of these are built on top of Spark Core as a way to do advanced analytics on top of the Spark environment. So again, Spark started in 2009. MLlib started in 2014, so 5 years later as an independent project, which was eventually brought in-house into the AMP lab. In 1.x or 1.6, it was really based on RDDs. And we, as of 2.2, started to move everything, all the algorithms, to data frames, mainly for performance reasons as well as ease of use. So one of the things that is important to understand about MLlib is really it's designed to be linearly scalable. How many people? Does anyone in the room know what linearly scalable means? Anyone? Okay, you want to give an answer? I'll make this interactive. This is a Saturday morning. Let's have some fun. What does linear scaling mean? That's true for linear algorithms. That's true. But for linear scaling,
like horizontal and vertical.
Yes, horizontal and vertical. So what that means is that if you were to double the number of machines, you'd theoretically cut the runtime in half. Or if you double the data and double the number of machines, the runtime will be held constant. Do you have a question?
We have this thing called Amdahl's law, right? It says that you can't really
True.
increase that.
In theory. It's in theory that it would do this. You always have the network and other kinds of limitations in the actual hardware. Sure. So the purpose of MLlib was really to build a general purpose machine learning library, so not special purpose like TensorFlow with deep learning. It's meant to cover a broad range of algorithms in machine learning. It's written entirely in Apache Spark. It's not like a fork where we've done some like third-party code base. It's written using all of the Spark operators. It integrates well with your agile modeling process, which we'll talk about in a minute. So some basics for, especially for the data engineers in the room versus the data scientists. The very simple way to think about a model is it's a function. So when you try to train a model, you're trying to learn that function from your data set. So a function, if you guys remember like high school algebra, is fx. So one of the simplest models is linear regression. Someone already mentioned linear regression. It's y equals mx plus b. You can have any number of n different variables. You're trying to learn the coefficients given your data set. So that's one example. Another example is a decision tree. So this example, we're talking about the mileage for your car vehicle, and that's based on a couple of if, then, else, much like Chris D'Agostino mentioned today. So if the weight is heavy, then you're typically going to have a high mileage car. If it's not, then you might have lower. If you have lower horsepower, then it's low mileage. If it's high horsepower, then you're still going to get low gas mileage on this one. So these are all models or functions that you'd build given your data set. So if you go to like any basic data science class, they'll give you this. You load up some data, you extract some features, you train a model, and you evaluate it. It's a very simple pipeline. The pipelines I usually see in customers look more like this. So you're going to have a bunch of different data sources. You have to join them all together, typically with SQL. You have to extract some features, do a number of different transformations, everything from text processing to normalization. You train a model, you train another model, you ensemble the models together, then you do an evaluation. So they're very, very complex. So one of the problems today is that most of the data science work, and I'm sure you guys see this in your organization, is done in very much prototyping environments. So usually it's Python, R, Anaconda, typically single machine type tools. And then when it's time to do it and productionize these models, they have to be re-implemented, typically in Java. I've had this case where people do it in C++ or even COBOL. So a lot of extra work. So there's different code paths for what you're doing in your prototyping environment. It always doesn't translate well to production. If you're doing things with pandas, for example, in Python, it doesn't really translate well into the Java world. It's very slow to update your models because you have to do a lot of recoding. So in Spark 1.6 and starting in early 2.0, we introduced something called model serialization. So what this means is that you can take the entire pipeline, not just the model, and serialize it and save it off to your file system. In this case, it's using S3. You can also use HDFS or any other file system to save off the model. And then once you've saved it, whether you're using Python or R to create that model, you can then actually load it up into a Scala or Java context to productionize it. So a couple of code snippets. So I'm doing the whole presentation on a deck today because that's how we set up the presentation. So I don't have a demo, but I'm going to, as much as I can, show you code snippets so you understand how to do this, and I'll give you a link to the actual notebook after the talk. So what you will do is you'll have this, let's say, logistic regression model. You call fit on the data set, and then you call write.save, and then you would save it to a path. So this will actually save out your entire model, your entire pipeline to that path. If you notice, this is how you do it in Scala, and then on the right is how to do it in Python. It's almost exactly the same from an API perspective, but you can use either language to do your data science work. When you save off the model, you'll get a couple different directories. One is called metadata, which is just the information about the training and so forth. I'll get into that in a minute. And then the stages, the actual stages of the steps in your pipeline. So the first one that I've talked about is metadata. So if you look at the far right side, the output, metadata is just the information about what the model is, as well as when you trained it, the timestamp, the version of Spark, the parameters you used when you trained the model. That's all saved in metadata. In the data folder is actually a Parquet file with the actual model itself. So the simplest model that we have one of the simplest models in transformers is a string indexer. Essentially, it's a hash map. Everyone knows what a hash map is, I assume. So the hash map in this case, you're translating these 9 values into an integer. So you're starting with like private, and when you send private to the function, you return 0. If you send never worked to the function, it'll return 8. So this is a very simple version of a model. It's not complex like decision trees or ensemble decision trees. It's a very simple model. But using this method is a good way to actually introspect your model. So once you've actually trained the model using a pipeline, you can actually take a look at it using this method. Once you get into the estimator stage, so this is logistic regression, this is where you're learning your coefficients. So much like the string transformer, you get some information about the model parameters that's stored in the metadata file. Then in the data file, which is in Parquet, you can actually import this to take a look at all of your coefficients as well as your intercept vector. So that's stored as a single row in a Parquet file, and so it's available to you as well in terms of transparency for that model. Okay. So if you're doing a different method, this is nonlinear. So this is, again, the decision trees. This is a single decision tree. You can also do ensembles. You'll see here that you can actually see all the splits, as well as to give you information about why we split based on information gain or impurity, depending on what metric you're doing for your splits. So we save all that off into a Parquet file again. So you can actually use this to do introspection of that model. Okay. Any questions so far on serialization? Good.
Is there a way to like sort of checkpoint where you are in the training, for example, in the model?
What do you mean by checkpoint? Basically, yes. So there is, if you...
Like TensorFlow, I would say.
Yeah. So if you set the checkpoint directory in the Spark context, and then not all the algorithms, most of them have a checkpoint interval. I usually set like 5 or 10 or some number like that. It'll automatically save off to either HDFS or S3. Yes. Your question?
What version did you add the serialization stuff in?
1.6 we started adding it. Yeah. Question? All right. So this is in Databricks. We also have the ability to visualize that tree. So this is a way to, this is just a table. But you have here like the top level, this is your root of your tree, and then all of the different children, left and right splits. You can also do a visualization of that in Databricks natively, or if you want to use like matplotlib, there's a tree visualization. So it's easier to see where the splits are and then all the different predictions kind of at the bottom of that tree. Okay, so now that you can serialize the model, you can actually start to think about how to productionize it. So we're going to talk about some of the requirements that I've heard from customers around how to productionize models. So again, productionizing models is not just one thing. People think it is, like, oh, just put up a web service, you're good to go, right? Not really true. I worked with a car company that wants to put their model in the car because it's not very efficient to be driving down the road with let's say your Toyota Prius, and you're in self-driving mode, having to call a web service that's down when you're at a stoplight. Wouldn't be very safe. So you can productionize model inside of a moving vehicle, inside of a car. Oftentimes, a lot of the mobile app companies will put the models into the phone for their apps. Even in embedded devices like medical devices, it's very common for them to do it at the endpoint, both for data privacy reasons as well as being more real time. How many people have seen this diagram? I love this diagram, by the way. I actually have a friend of mine that actually contributed to this paper. So this is a paper Google published in 2015 about their systems and how they do machine learning. So I worked at Google. I didn't work on the Google Brain team who actually published this paper, but I saw a lot of this within the Google infrastructure. And so what we saw was that Google has machine learning, but it's a box this big. So right here in the little middle is machine learning code. But everything around it is much, much bigger. All the configuration management, collecting the data, doing feature extraction, process management, serving those models, monitoring the models to make sure that they're up to date, as well as data verification. These are all much bigger pieces to the overall system for how Google does machine learning. So one of the things to keep in mind in terms of agile modeling, so there hasn't been as much many frameworks and methodologies around data science yet. It's still a relatively new field. And so one of the things that people look for is, how do I structure my view of data science and machine learning in a way that makes sense? So I borrowed this from Scrum, but it's very similar to what like ChrisDM, which is an IBM framework. The whole idea is that when you do data science, you really want to start with business goals. A lot of times you can do like open-ended data science and it's not going to lead you anywhere. So you want to set the business goal first. Then you want to understand your data. You want to create some type of hypothesis. So a lot of people look at data science and it's just like running SQL. Not really. Really what distinguishes a data scientist from like a SQL analyst is that you are a scientist. So you follow the scientific method. So you have to have a hypothesis before you start your work. You devise some kind of experiment to test your hypothesis. You prepare some data, you train, tune, and test the model, deploy it, and lastly, you measure and evaluate your results. The idea is that you want to actually do this very much like the scientific method. You want to be able to measure at the very end and have hypotheses at the beginning to track all of your work. So the focus of the talk is on deploying this model, but a lot of times people forget to follow this principle when they talk about deploying models. So one of the things that I've seen is people work on models for a long time, let's say 2 years. But there's no way to know that that model will actually work in production until it's in production. So I always advocate for deploying early and often and doing A/B testing so you get comfortable with that model. You can do all kinds of different cross-validation, other ways of doing testing that model, but until it's in production, you don't know if it'll actually end up improving your business or meeting whatever your business goals happen to be. So deployment should also support measuring and evaluating the model performance. And deployment should be fast and adaptive to business needs. So you should be able to deploy early and often. So A/B testing. How many people know what A/B testing is? Any graphic designers in here? Okay, everyone knows what A/B testing is. Awesome. So one of the things that people need to do in machine learning in particular, as well as data science, is really to have an A/B testing framework to actually measure the models. There's a couple different ways people do this. One is called benchmarking, so I'm jumping into the last bullet. What that means is that before you actually put a new model into production, you might just put it off to the side and just measure how it would have done if you actually used it. So in a very common use case in fraud, you might have your fraud model that's working really, really well today, but you want to try out a new model. You might put a benchmark model next to it and just see if it would have scored better than your existing fraud model. Another way is phase-in. So this means you would actually take 80% of the traffic and use your old model and 20% for the new model. And generally, I would avoid a big bang. Don't just like drop and replace models at any point in time, because there's a high probability that's very risky, and it could have a negative impact on your overall business. And this is a little bit controversial. So I work a lot with some of the bigger tech companies like LinkedIn, Google, Netflix. They always log exactly what goes into the model every time they use it. And here's why. One of the nastiest bugs they ever experienced was they thought that the model was totally off because it was not providing the right predictions. What happened was the original data, someone had changed their profile information, or people had changed their profile information, but because they didn't log and snapshot their profile at the time the model was run, they thought there was a bug in the model, but it was doing exactly what it was supposed to. They just didn't log exactly what the model was predicting off of. So it's very important to do this step. So a couple other kind of more ancillary requirements, really around thinking about SLAs, throughput, predictions per second, as well as uptime reliability. These are all important considerations as you think about how to productionize your models, as well as the existing technology stack. Oftentimes, the actual technology stack for where you productionize it is very different from where you would do training. So you could have legacy like mainframe, you could have C or C++, typically Java if you're dealing with a Java application server. Those are all environments that I've seen across the enterprise. So a couple different things to think about. One is, can I do my model in batch? A lot of models are batch. Even Netflix does their models in batch because you don't change your movie preferences every 3 hours. So every night they'll have a model, they'll train it, they'll figure out what the predictions are you for the next time you visit Netflix. So that's just saved off in a database. It's also similar for other like couponing tools and like Groupon and so forth. They'll do everything asynchronously in batch. The other way to think about it is real time. There's two types of real time. One is human real time, and the other one is real time, real time. It could be synchronous or asynchronous. So oftentimes you have to consider these types of issues and how accurate the model needs to be in comparison to how fast it is. So one of the problems with having really complicated fraud models, since I want to talk a little about fraud, is that you can't have a model that's too deep and too complex because it may not meet the SLA. It may take too long to run in production for it to actually be useful. So a couple other notes around open loop, closed loop, and online learning. So everyone, like when I first talk to people that aren't like super familiar with machine learning, they think they want to do online learning. Basically, the machine learns as you actually run transactions through it. It's a very bad idea. I mean, Ted mentioned this with Microsoft, that the chatbot became very xenophobic and racist and all these other problems because there wasn't the right controls to make sure the model doesn't overfit to the wrong data. And so when people talk about online learning, I would really recommend them, instead of using online learning through these online methods in MLlib, to use more complex models. So if you have a more complex model, you can handle those scenarios without having to resort to online learning. A couple other definitions is open loop and closed loop. You may want to consider, if you're early to machine learning, you haven't deployed models before, have an open loop, meaning having a person involved in the decision. So the prediction happens, but still a human being is involved to make sure that the model is doing as it should. And there's nothing wrong with that. Closed loop means there's no human involved, and you're actually doing the predictions in real time without a human being actually monitoring the predictions. So a couple different use cases. One is model scoring. So one of the things that's important, and I work with a fintech company that has to deal with bots. So one of the problems on any website is having a bot or a non-human being trying to access your website. So one of the things you got to consider is that you want to go beyond just yes, no. So the prediction might be yes, it's a bot, or no, it's a bot. There's also usually a probability or a score associated with whether it's a bot or not. You don't want to go to the full block of everything that you think is possibly a bot, because that would be a very bad experience on your website. Everyone's been to a site and says, oh, the site's down, or oh, you're not allowed to access this. I get this a lot because our VPN is provided through Amazon. And so if I go on my VPN and go onto my bank site, it'll actually block me because I think I'm a bot. So what you really want to think about is probability scores. In this case, the probability that it is a bot or not when you decide how to take action against your data. So if it's between 0.75 and 0.9, don't just block them, refer them to an agent. If it's between 0.6 and 0.75, maybe you want to send a SMS code to re-enter to have them re-log in, or maybe send a challenge question or just do a re-log in. So you want to figure out what is the right mitigation strategy given the probability that it is a bot or not just thinking about things as yes, no. Likewise, in terms of recommendations, a lot of companies have these kind of things for the online store as well as for, in this case, is a virtual store example, is really being able to keep rankings of the different items. So oftentimes you'll have a list of all your different things you sell, and you really want to rank those based on the probability that someone will actually buy them or propensity to buy those items. So a couple different options for architecting model scoring. Everyone just thinks about real-time, like doing real-time predictions, but this is a very valid way to actually productionize your models, and this is used often with ALS, which is alternate least squares. It's used for recommendation engines in various companies. So maybe you want to send an email to the customer around the recommendation you want them to buy. Then you want to be able to, well, let me start here actually. Let me start in the left corner. So with Spark, you'd actually train this model on a nightly basis, figure out the recommendations for your group of users. You save it off to a database, typically NoSQL, maybe it's DynamoDB, maybe it's Cassandra. And then on a regular basis, you send emails to customers. And then if someone actually goes to your website or goes to your application, then you'd actually just pull it from a database. You don't really want to be training and running ALS models while people are on the website. They don't want to be waiting for like 5 minutes for the predictions to come. So this is a very valid way that people will do predictions. Another way, and this is very similar to the bot example, is to do predictions asynchronously. So you may have activity going on your website. You want to compute some features. You will run a prediction. And then once you run the prediction, you want to save it to a cache. The reason you would do this is that oftentimes the actual intelligence around whether something is a bot or not isn't a single event. It's a group of events. It's how many times you're clicking on a page per second. It's how long you're waiting to enter data into a field. All the information could be intelligence that you need to actually put into your model to have accurate predictions, which is why you want to do this asynchronously in a stream. And then in the actual web application itself, is you have an API check periodically to see, is this person a valid user or is it a bot? And then based on the probability it is a bot or not, you make a decision to either kill the user session or send them a login page, et cetera. And the last option is really training the model in Spark, but actually doing predictions outside of Spark. So let me go back real quick. Both of these options are both using Spark. So this is using Spark Batch. This is using Spark Streaming. This is not using Spark at all. So this is an example of the recoding option that I talked about before, where you have to do real-time predictions. In this case, you train the model in Spark. You save the model to S3 or HDFS. You copy that model to production, and then you run it outside of Spark. You may load coefficients or intercepts or other information from a file, and as new data comes in, you're doing your predictions. Okay, any questions on that so far? Okay. So I'm talking a little about Databricks model scoring option. So one of the things people always ask about is, this is an option that Databricks has. It's a proprietary option, but because our models are very transparent, you save them off, it's all open source. You can also write your own. I've actually, for a company, given them examples of how to actually take the MLlib format, that model, and then actually do predictions in C or C++, because they ask for it. So you can also write your own. But this is an option we have that's a convenience option that for companies that are interested in doing their model scoring using Databricks. So it's based on option C, the one that I just showed you at the very end of the slides. So it enables using your existing model deployment system. You can achieve very low latency. I'll give you some metrics at the very end. And you can use it in custom deployments. So our goals are really to support faster time to production, support faster modeling operations, and trying out a bunch of different models as you do your predictions. Oops. So again, you'd fit the model in Databricks using Apache Spark and MLlib, export the model as JSON, and then deploy the model in your external system. It only requires one dependency. It doesn't require Spark, doesn't require Hadoop, nothing else, just one dependency, 50 megabytes called dbml local. So what we've done is actually taken the MLlib algorithms. Instead of having it running in a distributed compute, we actually run it on a single machine. So that was really the long pole in the tent in terms of what we needed to do to make it possible to run your models locally. So load the model from JSON at runtime, and we make predictions in close to real time. So the input-output is really simple. You pass in the JSON of the incoming data. This is showing in this case, passing in a vector, but you can also pass in the raw value. So if you have strings or other values, you can actually paste any kind of JSON string into the algorithm, and out will pop your prediction. So in this case, it's just showing the prediction as well as an ID value. You can also do the probability if you need it for your use case. So it's in private preview right now. So we have a number of customers trying this out. We don't support all models and all transformers in MLlib. We support the ones listed here, most common ones: string indexer, vector assembler, OHE, vector slicer, hashing TF, bucketizer, and tokenizer, as well as 3 methods: logistic regression and both tree and ensemble methods. So feedback is appreciated. We're actually working on all the other transformers as well as other methods in MLlib. It's just not there quite yet. So a couple of different metrics. So you have the tokenization. So this is an example where we're doing 3 different steps. We're tokenizing. We're having string data. We do a hashing TF, and then we do logistic regression as the actual algorithm itself. So it's pretty expensive. This tokenizer is a pretty expensive operation as well as hashing. We did an input size of 100 KB, so 10,000 different terms using this model. And this is our overall metric. So for P50, 2.3 milliseconds. Even in the P99.9 seconds, the longest run we saw was 17 milliseconds. So it's very, very fast in terms of running these models. If you were to use Spark to do the same thing, you're going to get barely 100 QPS. The whole point of this type of algorithm, the way we've done the local implementations of MLlib, was to be very, very fast and low latency for single point predictions. Okay, so I had an example here. I don't know if I can click on that. I might try to go back and I'll try to click on that next. So a couple of things. I have to do a quick plug for Databricks. So Databricks is the commercial company behind Spark. We have a version of Databricks that's free. So for those that are new that haven't done a lot of Spark, it's completely free, no strings attached. You can run it for as long as you want. And I'll give a version of the notebook you can actually run in your own environment in Databricks Community Edition. So that's free. So again, we have Databricks 3.2 just came out this week. It's cloud optimized. We have a caching layer called DBIO, as well as enterprise security if you are an enterprise. Okay. I do have one more plug. Did you want to cover Spark Summit Europe?
I can talk about it later.
Okay. Okay. So I'm going to see if I can I open that laptop? Is that possible? To show them a couple things? Oh, you can? Okay. Okay. I'll send you guys a link to the notebook. I have a demo that I can do, but yeah, so this is on a separate computer. So I'm happy to take questions or anything else you guys want to talk about. Oh, yeah. Well, one thing, we'll talk about Spark Summit real quick, and then we'll, yeah.
I just wanted to plug in. How many of you actually been to Spark Summit in the United States? Anybody here been to Spark Summit? If I had a T-shirt, I would actually give it to you. You're the only one. We're having a Spark Summit in Europe in October. So if you're a fan of, it's going to be in Dublin. If you love Guinness, that's a good place to be. October the 24th till the 26th. So check out sparksummit.org, and you'll have the link to register. Anyway, ready to take any questions for Richard if you have. Unfortunately, we couldn't show the demo, but we're going to publish the notebook, so you will have access to it. Any questions, please? Go ahead.
Sure. Just with respect to that DBML local library, is that something that's going to be open source, or is that proprietary to Databricks customers?
So it's proprietary right now. It's, as you guys would imagine, it's very easy. It's easier to open source than it is to close source something that's already been open sourced. So it may be open source in the future, but it's a Databricks project right now. And just to be transparent, one of the things that being not necessarily proprietary, but not part of the Apache Foundation gives us the ability to do is it doesn't have to be voted on. There's a lot less back and forth. And so since it's a very private preview or kind of an experiment, it makes it easier for us to get feedback from the community directly and then have this project to see if people appreciate it.
Yeah, I like the idea going the other way around. Anybody else? Yeah.
I was wondering, is there any upcoming plans to add GPU support, possibly in the machine MLlib? Right now,
Yeah, so we announced at Spark Summit West in June, Spark DL. So Spark DL is based on TensorFlow. But what it does is it allows you to actually use the same API you use with transformers and apply it and use TensorFlow in that. The couple of classes we have, one of them is a deep image featurizer. And so it's a way to translate an image into a matrix that can then be used in subsequent machine learning tasks with like one line of code saying deep image featurizer, here's my model I want to use from TensorFlow, and here's my rough image size, and you're good to go.
What did you say it was?
It's called Spark DL. Yeah, and that's completely open source, free to use, works with open source Spark. You can download it on GitHub.
Your own network.
Yeah.
Yeah, it's
Absolutely.
called Spark Deep Learning Pipelines.
Yeah.
If you actually go to our Spark Summit San Francisco keynote, Matthias Zaria was the one who actually introduced, and we actually had a talk on it too. And if you want to know more about it, just, okay, you did. All right. Anybody else?
I have a question for the model serialization. So besides the JSON format, does MLlib support other formats like PMML?
So we do support PML. We had it in 1.x. We haven't. We're kind of. So we're waiting for a community contribution for PML in 2.x. But one of the reasons we don't support PML because it doesn't support all of all the transformers. A lot of PML really support just the estimators themselves. So that's why we use our own kind of open format for how to serialize the models because PML wasn't complete in that regard. But it'd be good to get someone who would take the model that we have today, the format, and translate it like a PML. But it's just not there yet as of 2.2.
Any more?
PML is called Predictive Markup Language. So it's a standard, I think IBM, actually championed it. It's a little bit like, for those that may not do a lot of machine learning, it's kind of like PDF versus like Word format, very loose. It's really kind of like the standard, but doesn't have everything required that we would need to actually serialize the model like we'd want to. And so it's traditionally used as an export format. So you'd be able to export your model to PML, but again, it doesn't support everything.
Go ahead.
So do you guys support any financial model?
So what do you mean by financial model?
Think about like any algorithms about like so if customer opened the account, they wanted to set up some kind of model like what kind of account is, what kind of region the customer is opening the account. Some kind of like custom model.
Yeah, so we have a number of different verticals that we at Databricks support. Financial services is one of those, as well as we do a lot of work with genomic companies for drug research. So all of that is obviously highly proprietary to the company. And so if you have a company that wants to do financial modeling, they would actually use these algorithms at the base, where there's a lot of secret sauce in the featurization and which of the methods they use and so forth. So they start with, let's say, even logistic regression, and then do a bunch of secret sauce on top of that to create like a financial model like underwriting, for example.
Any other questions? There you go.
As far as getting model in production faster, what's your experience using notebooks? I mean, when your data science code in notebook and then
Right.
you throw it to data engineers or engineer, they record it or they reuse it. I mean, what's
Yeah, so we work with a big game.
general rules?
Yeah, well, it depends on how you productionize the model, but I don't know if I can actually, it's out of presentation mode. But on the first option, which is like scoring in batch, we have a big gaming company. They actually use the notebooks to productionize their models as well. And so every night they actually will run a notebook. They'll actually save all the predictions to Aerospike as their database of choice. And then whenever people go to the game and actually look at the online store, actually pulling it from predictions that were created by a Databricks notebook. It gives a lot of flexibility because a lot of this is experimental. And so what they'll do is at any point in time, if that model isn't performing or they want to do like an A/B test, they change the notebook and then they run the job again, and then you get new predictions on like a subset of their users to see, or players rather, to see if they're actually, if the model is effective.
So in the case when you do put notebooks in production, how do you handle like versioning and previous results so that you know what model was running when you made that decision?
It's a good question, yeah. So for this particular company, they actually have like a gold folder, and that's the one where they don't make any changes. They always clone into that folder. Other companies that are more regulated or more sensitive, they'll have a whole separate environment where the data science doesn't have access to that, and then they have a CI/CD pipeline, continuous integration, continuous development pipeline that will check in or check in a version of that into that environment to actually run in production. So it depends on like how big of a firewall you want to have between those two environments.
Is that using the Git backend of the notebooks, or is that separate versioning?
You do the Git or the Workspace API. So the Workspace API, you may not, I don't know if you guys have started to use that, but the Workspace API allows you to export all the notebooks as source code, and then you can then move them anywhere you want to.
I think we're about time because another section is going to begin. Please give a big hand to Richard. And we from Databricks, we actually have a booth right where the lunch, where the auditorium, just outside the auditorium, vendor section. If you have any questions for Richard or me or anybody else, please stop by. We'll be here till about 5 p.m. So enjoy the rest of the day. I'm doing a training, so if you guys have signed up, you'll hear me for another hour or so. All right, thanks a lot for coming.